Okay, so again, thank you everyone for joining us. I thought what we could do to start is, since we have a relatively small group, just go around and do a brief round of introductions. And I think it'll be helpful just for us all to know who each other is. And so we'll do that first, and then I'll have just a couple of brief introductory words, and then we'll get into the two presentations that we have here this morning. And just to make the introductions work smoothly, so we're not all tripping over each other, I'm just going to call on each of you for introductions in the order that that I've got people up on my participant list here. So I'm John Fischer. I'm with MassDEP. I'm our Deputy Division Director for Solid Waste. Why don't I turn next to Greg?
Hi, everybody. Greg Cooper, MassDEP. I'm the Division Director for Hazardous and Solid Waste at DEP.
And then Archie.
I'm Archie Filshill. I'm a CEO with Aero Aggregates of North America.
Great, thank you. Pat?
Hi, I'm Patrick Grasso, a partner in Urban Mining Industries here in Connecticut.
Great. Gary?
Good morning, I'm Gary Lambert, Assistant Secretary for Operational Services and the State Purchasing Agent.
Good morning. Robert?
Good morning, Robert Lowell, Deputy Chief Design and Engineering with MassDCR.
Betsy?
Hi, I'm Betsy Eisenstein. I'm the Director of Energy and Sustainability at DCAM.
Great, thank you. My order just jumped here. Brian.
Brian Kelleher with the Massachusetts Department of Transportation. I'm currently the Acting State Construction Engineer.
Great, thank you. John. John Tuska. Okay, we'll circle back to you, John. Oliver.
Hi, I'm Oliver Sellers Garcia. I'm the Director of Resiliency and Equity at the MBTA. I'm building out a new program on sustainability in the design and construction phases of our projects.
Great, thank you. Peter.
Hi, good morning. Peter DeBruin, Climate Mitigation and Resiliency Program Manager at Massport. I sit in capital programs, so sit in a lot of the design and construction meetings. So just curious as to what opportunities there may be going forward. Thank you.
Thanks for joining. Ryan.
Hi everyone, Ryan Kingston. I'm with the Department of Energy Resources Leading by Example Division, working with state entities to just disseminate knowledge about sustainability practices and clean energy.
Scott.
You're on mute, Scott.
Sorry about that. I'm Scott Callisti. I work with the Mass Division of Capital Asset Management.
Great, thank you. And then Tyler.
Good morning, folks. I'm Tyler Arrigo with Massport, working on their sustainability programs.
Great, thank you. And then John, are you there now? Can you unmute yourself?
Yeah, Assistant Director of Grounds at UMass Amherst. Just curious to hear what you have to say.
Great, thank you. Well, thanks everyone for joining us here this morning. I think it's actually got a really great group of people on relatively short notice, so I'm excited about that. So, you know, a few months back, we had our initial kind of kickoff meeting for this state agency recycling market development council. And at that meeting, it seemed like there were some, you know, varying type of purchasing opportunities for state agencies. And some were really particular to state agencies involved with construction projects. And they didn't really apply across the board, but, you know, opportunities that applied specifically for state agencies doing construction, whether it might be horizontal construction like roadways or, you know, vertical construction like buildings. So at that time, we thought it'd be helpful to have kind of some spin-off sessions focused on particular recycled content procurement activities specific to construction projects, and invite, in particular, the state agencies involved with overseeing those projects. So today we have two companies with us, Aero Aggregates and Urban Mining Industries. We're both involved with producing recycled content glass products for use in various construction applications. Actually, neither one of these businesses is currently located in Massachusetts, but both are seeking to develop sites in Massachusetts. And I think increased purchasing here in state will certainly help drive that investment. And then if that investment can be made, that also in turn helps ensure a reliable and consistent supply chain for the products they're producing, which is at our last meeting, we talked about some of the really important elements of these products being cost and competitive cost, performance and performance relative to their, virgin content counterparts, and then also availability. So, as we're working with state agencies on purchasing, we want to make sure that, any recycled content purchasing opportunities meet all those standards. So, that the products being made available are readily and consistently available, that they meet the specs that agencies need for their projects, and that they're available on, a cost competitive basis. And in this case, I think these products are very promising in that regard. So we're excited to have these companies share their products with you today. So they'll each in turn have some presentations to share with us today, and then we'll have an opportunity for Q&A about the products and to learn a little bit more about them. So we're going to go in alphabetical order here. So I'm going to turn it over to Archie from Aero Aggregates first. And Archie, if you want to go ahead and share your screen here.
Can you see that okay, John?
Yes, looks good.
Great. Okay. Well, thank you. Thanks for setting this up, and thanks for having us speak at it. And after listening to who's attending the presentation, I'm even more excited to share some of the stuff we're doing, because a lot of it is in and around the Massachusetts area. But my thought is just to give a quick background for those of you who are not familiar with foam glass aggregate, just a quick background of what we do. So we actually are a manufacturer of aggregate, and the acronym ULFGA stands for ultra lightweight foam glass aggregate. This is a material that's been around and in use in Europe for over 30 years, but relatively new to the US. Aero Aggregates was the first company to bring it to the US back in 2017. Its key properties you can see on this slide. It's an ultra lightweight material. It's a closed cell foam, which gives it great insulating properties. Works well as a drainage layer and a capillary break, and I'll show you why that's important in some applications, and some seismic benefits, maybe more applicable for the West Coast, but still some projects being designed on the East Coast for seismic. The reason we call it ultra lightweight, the material is 85% lighter than traditional aggregates, which kind of puts it in the styrofoam classification. At a bulk density of 15 to 20 pounds per cubic foot, that makes it much lighter than even traditional lightweight aggregates, which are usually in the 60 to 75 pounds per cubic foot. Like John started the introduction, we are made from 100% curbside recycled glass. And one of the things that's unique about our process, there are some products made from recycled glass. The benefit of the foam glass process is we can basically take any glass that nobody wants, which means it can be mixed color, it can be smaller particle sizes that can't be color sorted. These are all glasses that are not good for anybody in the container market or fiberglass market. So the glass we use is 100% diverted from landfill. Our process is when the glass comes in, we clean it. And cleaning it really means taking the plastic and paper off of it. And then we mill it into a powder. So on the left here, you can see what the color looks like after it's been cleaned. On the right is our milling operation. It's a pretty substantial operation. It's a 23-ton mill that takes the cullet you see on the left down to a very fine powder, basically a talcum powder. So that mixed colored glass, when ground down very fine, turns into a white powder. That white powder is then mixed with a foaming agent, and we used a recycled mineral for that, a silicon carbide. So when they cut silicon carbide for solar panels or for piping, the dust that comes off of that is collected. But we're only adding 1 to 2% of that into the mix, and then it goes through a heating process. And basically in this heating process, it's a multi-cycle heating process that sinters the glass. So we don't melt glass, maybe like you've seen glass blowers bring it down to a liquid. We're just heating the powder up to soften it. That activates the foaming agent, and then it basically builds it up into a cake, into a solid cake, like you would if you were baking bread. And this process is a 24/7 operation. So up top on here, you see the blending operation. It drops onto a conveyor belt, and this conveyor belt runs 24/7. On the opposite side of the solid cake of foamed glass. It's almost about 2 inches high. And what you'll see is that it's leaving that kiln at about 800 degrees Celsius. So that rapid temperature drop puts thermal stress in that cake, similar to you taking a glass out of the microwave and then putting it in cold water, right? And what happens is it starts to crack the cake. As it comes down the cooling line, it starts to crack, and at the end of the cooling line, it drops off as aggregate. So our standard particle size is 1.5 inch aggregate. We have a lot of contractors that get very disappointed when they want to see our crushing and screening operation and realize it's all done naturally by Mother Nature through this thermal stress. And then we ship it and we stick it outside. And this is a large pile of aggregate for a large project that we had at Philadelphia Airport. But because it's glass, there's no leaching, there's no concerns about the durability of the material because there's no effect from UV, no effects from weathering. It's a closed cell foam glass, so it does not absorb any moisture. One of the things that we like to point out, there are different types of foam glass. The two biggest distinguishing features is open cell and closed cell. We're going to talk about closed cell today, but we do have the ability to make open cell. Open cell actually absorbs moisture and is very big in the horticulture, agriculture market, where you can mix this with soils, especially like on a green roof. And what happens is when you water the soil or when it rains, the aggregate will actually absorb moisture and hold it and retain it in the soil. So as the soil dries out, the aggregate has the ability to release that moisture back into the soil. So you have a lot better yields and growth capabilities in soils with that moisture and oxygen layer at the root zone. So very, very popular in green roof soils. Here on the left, the closed cell is what we focus on at Aero. There are two processes, a wet process and a dry process. The wet process is used more for insulating properties. It has good insulating values, but about 1/3 of the strength. Because most of our projects are based around construction and infrastructure, we use the dry process. It gives us a much higher strength and still very good insulating properties. To give you a quick overview of some of the applications, these are just some cartoons of all the applications we do, from raising roads over soft soil. So for the resiliency people in the group, this is where you have areas that are flooding and you need to raise the grade. We can eliminate or greatly reduce the amount of ground improvement where you see them driving steel piles or concrete piles into the ground to get down to competent soils. Backfilling behind walls and bridges, roadway widening, backfilling over sensitive utilities. You're widening a roadway with an existing utility that can't handle new weight. So instead of replacing that utility, you can actually put lightweight on top of it so it doesn't feel any new weight. And in some areas where you're right at the frost depth level, you can actually insulate that utility to make sure it stays, not affected by any type of frost because of the insulating properties. And some of the commercial applications are just backfilling around foundations where Using foam glass, we can show we take 80 to 90% of that lateral load off of a foundation, which is a huge amount. Now you can start to optimize the thickness of your concrete wall. If your concrete wall, whether it's a basement or a bridge abutment, is 6 foot thick with traditional soils, by using foam glass, we can cut that concrete almost in half and the steel in half, because it's going to be feeling 80 to 90% less weight against it. And then the other markets we talked about, the green roofs and plaza decks. But one of the bigger tailwinds that we've seen since we first started is the whole push now for resiliency planning for storm level flooding. This is a little cartoon basically to show that if you're in areas that are prone to flooding, you now have to increase the grade to get above that flood zone. Well, that additional fill creates a load, which creates settlement. So what we're working on multiple projects now are showing engineers and designers, by excavating 1 foot of soil, you can come up with 6 feet of foam glass and have 0 new weight. If you have 0 new weight, you don't have to worry about different types of ground improvement and foundations, because you're not increasing any load on the compressible soils. But the biggest win that we found with both public and private developers are the fact that when that storm surge comes in, our material, foam glass, when it's compacted, has a 40% void space. So you can actually absorb a lot of that stormwater into the foam glass and promote infiltration. And especially in states like Massachusetts, the added benefit of that is, because the aggregate is an insulator, you never freeze the subgrade. And if you never freeze the subgrade, that means you're getting infiltration all year round, where a lot of the northern states have issued that their infiltration beds freeze up in the winter, and then you just have surface flooding. This is our best example. This is down in Long Island, a 10-acre site that had to come up 6 feet because of sandy elevations. They brought up 4 feet with foam glass, you can see back here, capped it with 2 foot of soil. And this was done purely for geotechnical and economic reasons. They used the foam glass. They were able to eliminate all their piles in this area. But then they had a lot of underground stormwater basins to manage stormwater. Well, we were able to go back with the developer, which is Avalon Bay out of Massachusetts, and get them stormwater storage credits from the town of Hempstead, in addition to just having the lightweight fill. Providence, Rhode Island, another example. This is the 610 interconnector, where they had to raise these bridge approaches up 30 feet, but there was a 100-year-old brick sewer underneath one that could not allow any new weight. So this is the first 20 feet where the engineers were able to excavate 6 feet of soil and bring in 36 feet of foam glass and have 0 new weight on that underlying utility. So this is 36 foot high, completely backfilled with foam glass on both sides of this ramp. So this job was completed 2 years ago in Providence. But closer to home, Logan Airport. I know there's some people from Massport. This is our 3rd phase at Logan Airport. We're starting this year. This picture here is from phase 2. These are the ramps that are coming up between terminals B and C, and Mass Airport. The Logan Airport is on fill soil, so very soft compressible soils. The original design was to undercut 16 feet with sheeting and shoring and dewatering and come up with traditional lightweight aggregate. But when they learned about how lightweight the foam glass was, they were able to do a 3-foot cut and bring up 20 feet of foam glass with 0 net surcharge. So very cost effective, and probably took 90 to 120 days off the construction schedule just based on reducing that work. This is another resiliency project just north of you, Route 4 in Durham. This roadway, it's a tidal area that was flooding out, so it had to be widened and raised. So the dotted line was where the additional embankment was. It had to come up higher, but if they increased that, it would cause weight on that soft soil. So they excavated, backfilled this green area with foam glass, put the new roadway on it for no new weight. And there's the new roadway after it's been completed at the highest flood level. So the roadway is now out of the flood zone, and this whole section of roadway is built on foam glass. These are plaza decks in New York City off the High Line. There's the finished one. And in this case, they actually call this a blue roof because they're using the thickness of the foam glass under the pavers as stormwater storage to release the stormwater off the plaza deck slower. So that's about 3 feet of foam glass under these pavers. Reconstructing existing piers. A lot of work is being done on multiple states now where they're going into old piers and increasing the height of the pier, but the original piers aren't designed for that additional weight. So foam glass is a way to increase that height without surcharging. And in this case, it's also a benefit. This is New York City. Burrowing animals will not chew into foam glass. So it actually is used as a rodent barrier as well. This is the RCA Victor Pier in Camden, New Jersey as another example. This is a 17-foot high mound. It's a green park looking back at Philadelphia. A 100-year-old pier couldn't handle additional weight. And there's the pier completed. And this whole pier is backfilled with foam glass. And by coincidence, this new Garden Inn hotel here is all first floors on foam glass. Raising a bridge on I-80 in New Jersey, where they were able to use the existing abutment. They did not have to replace the abutment, even though they had to put more fill on it. The abutment's been there for 40 years. They just excavated soil and brought up all the new fill with foam glass and poured an extension so that the original abutment feels no new weight. So to me, this is sustainability at another level, right? They didn't have to reconstruct an entire bridge abutment on I-80. Widening of I-95 down in Virginia, where they're filling in this valley, and the concern was putting stress on these bridge supports. So by bringing up lightweight, it reduces any of that lateral stress. They could fill in that center lane to widen I-95 without any concerns on the structure above it. Same thing, this is into the Port of Norfolk. This is the Frederick Douglass Bridge coming out of Washington, D.C., where they're building the embankment to the approach. I'll go back one. I don't have slides in here, but after I saw the introductions, I probably should have had them in there. We are working on our first job with MassDEP, which will be starting later this year. And also for MBTA, we were used on several phases of the Green Line extension. Probably the biggest extension is where they were putting up the lagging walls, and they were very much concerned about the fill on this wall rotating this. So instead of increasing the size of the steel in the foundations, they were able to use a traditional sound wall and backfill that with ultra lightweight and take that load off, which kept the design optimized for that wall. I have pictures of those if anybody's interested. We have some case studies written up, but I wanted to point that out. And then the other thing that we promote, even though we are putting something in Massachusetts later this year, is the sustainability of the trucking of these aggregates. Because they're ultra lightweight, if you look up here, you've seen these on the road, these are mulch trucks. This truck can hold up to 100 cubic yards. So if you're delivering material via dump truck, you're usually getting 13 to 14 cubic yards on a dump truck. So with one of these trucks, we can deliver the equivalent of 6 to 8 dump trucks of typical fills. So when we look at our largest project to date was at Philadelphia Airport. We did 100,000 yards underneath an apron for American Airlines. We reduced the number of dump trucks coming in and out of the airport by over 6,000 dump trucks for one project, just because of how much material we can get on a truck. Further afield, we can put them in large bags or even sea containers where we bag the material. And you've seen enough of these, but this is basically just showing we're taking consumer glass, converting it back in, and then optimizing the number of trucks. So we look at CO2 reduction all the way throughout the cycle. The facility that we're looking at in Massachusetts will have 2 lines, which means it'll be about 30,000 tons of glass, or the equivalent of about 140 million bottles diverted from landfill each year at that facility. As a company, we hit our 500 million bottles diverted from landfill this year. And with our new facilities, only one in Florida, Mass will open up this year, and Modesto, California in January, will be on track to divert the equivalent of about 500 million bottles per year. And I don't need to read the last slide to you, but a couple of the bullet points. I think for this group specifically, because after listening to the introductions about the focus on resiliency and sustainability, I do think it's important to note that when we started this back in 2015 and 16 and made material in 17, none of these projects were done because of sustainability or because of the greenness or recycled content. We actually took the approach, and our concern was that if we came out and said we have this great recycled product, most of the engineering community, sucks back about a foot, says that's going to be too expensive, it's not going to work. So we turned the table, and we spent about 5 years, from about 2012 to 2017, doing R&D, proving out the technical, proving out the economics. And once we got some of these larger projects in the ground and case studies, wasn't until then that we came back and said, oh, and by the way, if you care, this is kind of really green at the same time. So I think I've kept it under 20 minutes as promised, and I'll stop there.
Great, thank you, Archie. I did see one question that came in from Robert Lowell in the chat. Does the material float with density, given the low density of 15 to 20 pounds per cubic foot?
It does. So we're on a lot of resiliency projects, including probably the best one is that job in Durham, New Hampshire, that's underwater twice a day. So we did a lot of full-scale testing for buoyancy, and we are slightly buoyant. So our uplift is negative 15 pounds per cubic foot when completely submerged, which means for every 8 feet of foam glass completely submerged, we would need at least 1 foot of cover soil to keep us from lifting. So in all of these DOT projects that we're working on with state DOTs, the road box is usually more than enough to keep the buoyancy in check. Usually we're seeing 3 to 4 feet of height increase. It'll be totally submerged. So the road box being usually about 2 feet is more than enough. But I say this, we have all these technical notes and backup test data on our website if anybody wants to do a deep dive or have a call off of this.
Great, thank you. And I also wanted to note, I mentioned at the beginning that we're recording this, and we can share that, and we can also share the presentations from both companies with folks after the meeting here today.
I saw Ryan raised his hand.
Yeah. Do you want to go ahead and unmute yourself, Ryan?
Yeah, thanks, John. Actually, I'm wondering if you can speak about sort of embodied carbon. Many of us are trying to navigate this space of measuring and accounting for embodied carbon in our projects. And I'm just wondering if there are like EPDs for your product, or if in those cases where you've replaced steel and concrete, have you looked at the sort of emission savings from using your product as opposed to others? Just wondering if you can speak to that world a little bit.
Yeah, so we've just started the LCA process. As you know, it takes quite a while. It's about a year. One of the things that we are doing in Massachusetts, we're putting in electric kilns so we can take advantage of renewable energy. In Pennsylvania, it's natural gas. So our kilns going forward will all be electric kilns. We are working on LCA with the University of Illinois to create an EPD eventually. That will probably be, it'll be within a year, but probably at least 6 months out. But the biggest ones that we look at for carbon footprint are the less trucks on the road to deliver the material, the fact that we're using 100% recycled content. We don't require a roller. Our material goes in about 4 times faster because of a 2-foot lift thickness, which means less equipment shooting out CO2 to place the material. Oh, and there's another one, Ryan, it's left me. But they're kind of our key focus is that we looked at reduced carbon footprint. The second phase for us, and that's what I was going to say, is we see such a big push to get reduced cement. And so now we've got a full study now looking at how much we can reduce the thickness of a concrete wall. So instead of doing, we can actually reduce cement content by reducing the amount of concrete required. But it's also probably a great segue too for the next presentation as well.
Yeah, thank you.
Yeah, thanks. So we can take more time for questions at the end. We should have some extra time at the end, but Yeah, why don't I turn it over to Patrick now from Urban Mining Industries. And Patrick, if you want to go through your presentation now.
Thank you, John. John, is my screen up? Can everyone see that?
Yes, it looks, you should be all set.
Okay, good. Good morning, everybody. Thank you again, John, for putting such an important group together for us. So appreciate the opportunity to be in front of you. So we'll just talk a bit more about what we're doing, which is in some ways similar to what Archie's doing as well. So we're taking, again, some of the same challenge product you see here on the left, this MRF glass. We're cleaning it even to maybe a higher standard because we have to for the way we're using it and creating this very fine powder called ground glass Possolan. The product is called Positive, is our brand. We've been at it for quite some time. And we're building things like these projects you see on the right here. This is recently completed or under construction Oxford School here in Connecticut and the New Canaan Library, both taking local glass, processing and putting it into a low carbon, high performance concrete, cement replacement in concrete. Again, broadly, that's what we're doing. We're making a ground glass Possolan. It's creating a longer lasting and low carbon concrete that is providing a large scale, cost effective solution for glass in our region. The top is it's the beginning of our process. The bottom is some examples where it got used in precast steps and a finished concrete floor in a high rise project in New York. We've been at it for over 10 years with a validation plant upstate New York. So it's not a new concept. We've had it in place now for quite some time in a wide range of projects. Shipped the product as far as Google's headquarters in California out to Vancouver. Work with I'll show you examples of where we are in Yankee Stadium, Second Avenue subway, and elsewhere. But through that little plant, it gave us the opportunity to really seed the market. We opened up a large scale plant in nearby you all here in Connecticut, Beacon Falls, Connecticut. Welcome the opportunity to have you, should any of you want to come see what we're doing firsthand. This is the plant. Again, we manufacture and ship the product as a bulk powder out in tanker trucks, very similar to the way cement is transported. The photos on our right are our mills, a little different milling process than Archie has, and just getting it again because of how it behaves as a Possolan. We need to get it to even a finer, cleaner powder for the use that it has. Without getting too geeky here with chemistry for everybody, but I think it's important to understand why using ground glass Possolan is so important to concrete in terms of its performance benefits. When a ground glass Possolan by itself is an inert, compound, but when in the presence of water and cement, when that hydrates, two things happen. Some good stuff is manufactured, the calcium silicate hydrate, and the bad stuff, calcium hydroxide, is formed. The good stuff is the glue that creates the concrete. The bad stuff has a deleterious effect and weakens and causes porosity in the concrete. A Possolan such as glass is very high in silica. So it gives up a silica atom binding with the bad stuff, creating more good stuff. So that's the fundamental reason why glass is so good from a performance point of view in concrete. It's not just being used as a filler, an additive, or an aggregate. There's an important chemical reaction that I think is important for everybody to understand, and the value that it adds from a performance perspective in concrete. Again, the bottom photograph was used as some architectural block in the Children's Hospital in Philadelphia. Archie touched on some of these issues, so I'll go through them kind of quickly here. On the glass front, again, to go back to bottles, you've got to color sort. It's hard to do below 3/8 of an inch in size. You need to get ceramics and porcelains out because they have a different melting temperature than glass does. It causes chaos in the furnaces of bottlers or fiberglass manufacturers. Virtually no home for CRT paddle glass, limited home for demolition of plate glass. Our solution really takes care of all of that. As Archie mentioned, when you clean and grind glass, it becomes a white powder. We don't need to color separate. We'll take all colors of the mix. We can use ceramics and porcelains because they themselves are pozzolanic in the reaction. So not only do we not have to remove them, they're additive to the equation The challenge has been cleaning MRF glass. That's probably our biggest challenge. I've got a photograph somewhere here later, shows you how rough some of the glass in Massachusetts is in Connecticut. And that's really been the big challenge to deal with using MRF glass and putting it back into production. On the concrete side, most of you are aware of the big black eye that concrete has, the big carbon footprint that it creates, coming primarily from cement, and we'll talk about that in a minute. There are a lot of good state initiatives underway. We hope Massachusetts will join some of the other states that are looking to create low carbon concrete initiatives. Some of you may know there is a shortage in other pozzolan markets. Those markets historically have been fly ash and slag. Fly ash coming out of coal burning power plants. We converted or shut them down. And slag coming out of the manufacturing of steel, which we do very little in the US, and most of it's imported. So what's happening is you're getting a diminishing supply of these historic pozzolans, such as fly ash and slag, at an increasing demand because everyone's searching for ways to make concrete low carbon. And those two had been the historic two components that have been doing that, albeit by a post-industrial product. Now glass could fill that void as a post-consumer product and backfill some of that, the void that's created by the diminishing supply of those two historic components and the increasing demand for low carbon concrete. The other thing is the industry is looking for a consistency in product performance. What's great about glass, it's a very consistent chemical composition. So you know what you're getting every time you put a ground glass pozzolan in the mix. It's very consistent in its chemical makeup. And we'll try to be very consistent in the product we're making as well in terms of product size and its performance. There's been some talk in the past, well, you can't use glass in concrete because it has a deleterious effect. It causes things like alkali-silica reaction, a gel that would form on large particles of glass that would cause damage to concrete. Well, that's true if you try to use glass as an aggregate in concrete. But when you mill it to a fine powder, such as we do as a pozzolan, it actually reduces ASR. So it has a positive impact on concrete and this issue of ASR. So that's an important thing to know if people ever say, well, you can't use glass in concrete for that reason. And the industry has been slow to change. It's been one of the reasons why it's taken us 10 years with a product validation mill to get things to where they are and the ability to create this first plant. It's taken us 4.5 years, and we finally have a new ASTM standard specifically for ground glass pozzolans, C1866. So that's given architects and engineers a lot more comfort in being able to specify glass and concrete more freely. The other thing that just happened after, again, a 4-year plus effort is New York City DOT was able to include it in their specs for roads and sidewalks in New York City, which is really important because not only is it DOT work, but any private sector work on any sidewalk in New York City is subject to DOT standards. So that was a big breakthrough as well that happened in the last month or so. The two dual benefits of glass and concrete are really environmental and performance. They both go hand in hand. As Archie said, you need the performance, I think, or the environmental really is of no value. But on the environmental side, and I'll show you some numbers in a second, but it's a big significant reduction in the carbon footprint of concrete. Many of you, again, you've heard numbers to make a ton of cement, you generate a ton of CO2. This is almost a ton for ton savings because the carbon footprint of this product is about 5% of that of the cement that it's replacing in concrete. So that's really the great story for concrete, its ability to reduce that carbon footprint. It can take any color glass, it can take ceramic, so nothing needs to go to landfill. It yields a whiter, brighter material, which helps reduce the heat island effect in our urban areas. The photo on our right shows 3 pours we did for the city of New York City DOT, 2 full blocks sidewalks. The bottom is with a 20% positive replacement. The middle is with a 30% fly ash replacement, and the top is with 40% positive replacement. So you can see how bright white it makes our urban sidewalks. And it's useful in parking garages as well in terms of reducing the need for lighting as well in a bright concrete structure. It's made and used regionally from regionally harvested post-consumer project glass, again, minimizing the long haul transport that we face for alternative uses. On the performance side, and I didn't really incorporate it today, but I can follow up with all of you later, a lot of the slides that really back up these statements. But it creates a better performing and longer lasting concrete by a good measure on many fronts. It reduces the effervescence, the white powdery material that bleeds from new concrete. It reduces shrinkage, which means less cracks. It uses less water because glass doesn't absorb water, which yields typically less water means a stronger concrete mix. But the big thing that our DOTs are focused on throughout the country, particularly in the Northeast, is its resistance to chloride penetration. CCNY have done some extensive testing with the product. A woman got a PhD in it, as a matter of fact, showing that a mix with positive is 5 times more powerful in reducing chloride penetration than a cement mix alone in concrete. It's better than fly ash, better than slag. So that's kind of the exciting thing, because what happens is this photo on the right, when moisture and salt gets into concrete, you get that kind of failure. So it means longer life and, hopefully longer term savings for our infrastructure cost as well. This graphic just visually makes the point that while cement is only about 10 to 15% of the mass of a concrete mix, it makes up about 80% of its carbon footprint. And it basically accounts for 7 or 8% of the global CO2 emissions from the production of cement. The global warming potential positive is just 5% of the cement it replaces. It's really, we've got a life cycle assessment on our website. You're welcome to look at it at your leisure. It has for glass to concrete by far is the greatest positive climate impact compared to other options. This is something that the state of Oregon shared with us, Department of the Environment, the equivalent of their DEEP out there. The top bar shows the energy that's used to make glass, and everything below are the alternative uses for glass. Oregon's got us actually equal to or exceeding the climate benefits of taking bottles and sterilizing them and putting them back into use without even melting them. So they did a lot of work on this, and they've probably been one of the biggest independent supporters of using glass and concrete from a climate perspective. So again, this is work from Oregon, not our chart, and we're pleased to have it. Again, the product can be used in anywhere that cement is being used in a concrete mix, right? In cast in place concrete, we're probably in over 100 plus applications with our partner ONG Industries, which is Connecticut's biggest ready mix company here in Connecticut, using it widely. It's in pre-stressed concrete planks, probably in about over 500,000 square feet of that. We built high-rise affordable housing in New York using those planks and structural block made with positive. That photo on the right is Carnegie Mellon. We use architectural block and brick. Our favorite story is the one on the left, the UN Plaza. We took the window glass from the renovation of the General Assembly building, cleaned it, processed the glass into positive, gave it to Unilock pavers, and it sits on those pavers outside the UN as we speak today. So a great circular story, and it was one of the early ones that we were involved with. This was a big turning point for us for using glass in concrete. Hallett's Point in New York, first structural high rise nationally, maybe internationally, to use glass in a structural pour. So this kind of took it out of blocks and bricks and pavers and sidewalks and really brought it to the big leagues in structural use. The Durst organization is now planning to use positive for the entire building of the second phase of this project. We've got 7,000 or 8,000 tons of material positive. We'll go into that. Other examples around New England, the ESPN headquarters, the residential project here in Stamford. Bottom left is a UConn facility, and the bottom right is a new Canaan library, which is now under construction, again, using local glass going back to a local project. The Oxbridge School on the left, same story again. We took glass from Connecticut to lower Southwest Connecticut, processed at our plant, gave it back to the school here in Darien. So again, another great local story that people love. But probably our biggest and most high profile pour right now is the JP Morgan Chase headquarters facility on Park Avenue. 2 million square foot tower. Every concrete slab, every floor in this building will have positive in it at about a 30 or 35% replacement. So this is really kind of our biggest project right now, and maybe probably our most high profile project, which we're very excited about. Just, in closing, I could share many performance slides with you all later. I think on the planet side, this may be probably the most holistic solution from a climate perspective and environmental perspective. You can replace up to 50% of the cement and concrete with a ground glass positive, having effectively reducing the global warming potential by 42% of that yard of concrete. It's better than anything right now out there in terms of doing that. You can do ternary blends actually with slag and actually go further between the combination of slag and ground glass pozzolan. We're doing testing now to replace up to 70% of cement and concrete. From a health perspective, we didn't talk much about this, but it contains no heavy metals, which you sometimes find in fly ash and other pozzolans. From an equity perspective, we talked a bit about how it reduces heat island effect, which is really often it disproportionately occurs in our low-income neighborhoods. So we think it helps on that front as well. And again, on the circular economy story, just being able to utilize regenerative waste glass that's available to us in a stable supply. So I try to stay under the time as well. Just in closing, what can you do? Obviously, keep glass in the collection stream. I know some of the communities are also, are stressed about trying to use glass because it has very limited home right now. Specify high performance, low carbon concrete and concrete-based products using a ground glass pozzolan in your projects, in your towns and communities and state projects. It does multiple things. It solves the historic challenge of waste glass. Between what we're doing, what Archie's doing, I think we have a home for all the glass in the state. It significantly reduces the carbon footprint of that concrete. It enhances the performance of that concrete, and it'll extend the life of our region's infrastructure. So, John, I think I try to stay under 20 minutes as well. I'll open it for questions. And again, there's a lot more backup as Archie has as well in our product and its performance we can share with you all in a follow-up email if you like.
Yeah, great. Thank you. Thank you, Patrick. So I think at this point, I'd like to open this up for questions for either Archie or Patrick. I know there's one question that came in earlier from Jay Mitchell. Can you leverage other types of glass, e.g. storefront windows or just bottles? So I think, Patrick, you actually addressed that in your presentation that you can with pozzolan, but I also wanted to put that out to Archie as far as ability to accept any other glass beyond bottles and jars and things like that. Is that possible?
Yeah, and most of ours are bottle and jars because that's coming from the MRF, but plate glass from windows is absolutely acceptable. The only glass that we steer away from in large volumes is borosilicate glass, like the Pyrex, because that's been treated not to react with the heat. And because our process relies on that thermal breaking, that's the only glass that we keep out. Windshields that have the films in it, that would have to be separated. So most of it's container glass, but plate glass is definitely usable in our process.
Patrick, anything else to add from your perspective on other types of glass?
Yeah, we did a fair amount of testing and work with Staples years ago and a couple of universities to make the case for being able to use the panel glass from a lot of our electronics. So that's another thing. We've got our hands full right now with using MRF glass, but we want to expand that line as well and provide that solution. But no, and pretty much any glass works with us. We've got to clean it to a very high standard. The fact that we're not melting it and there's really no chemical reaction in our process, and the fact that the ceramics and porcelains are pozzolanic, they're okay with us.
Okay, great. So Patrick, if you can stop your screen share, that'll open up the screen for people's video. So I just want to open it up to people with any other questions for Archie or Patrick about their presentations or their products.
Patrick, I had one question for you in regards to the glass. Have you guys done any study on long-term ASR issues at all?
Yeah, I'm sorry, who was that speaking?
Oh, it's Brian Keller from MassDOT.
Hey, Brian, how are you? Some, I've got to check with my partner how far out they go. I know, but I think Rich Mulcahy in your shop, I think, has been doing some testing with us. I don't know whether he's doing anything independent on that. But whatever we have, we're happy to share with you, and I'll just check on the term of that testing so far.
Nope, I know Richie was working on it, so I figured I would ask. Thank you.
Good. I think the other thing, by the way, the other application here for glass in the state is something we did a year or so ago. We took glass and we actually made paint out of it as well, because it becomes, when we clean it and mill it so finely, it is such a white, bright substance that we can use it as a paint filler. We painted about 20,000 square feet of Westchester County's Department of Environmental Services in Westchester with paint made with positive. So it's one more application, another home for glass that I think we can expand over time with you.
I guess I have one question for both folks. Is kind of like, are there limits to the, one of the things I know is key for state agencies is, if I order it, am I going to get it? And are there kind of project size limits or cubic yard limits or something like that they could be cognizant of, or what the minimum is, maybe what the maximum is, just to kind of, that helps, I think, folks who have projects kind of go, okay, this one can fit, this one may be too small, that kind of stuff.
Archie, you want to go first? Sure. And it's a great question. One of the benefits that we've seen, and it's not a perfect world in that regard, but the larger projects that do need material, the ones we usually have the most upfront sight on, were involved early on. So we've had projects as large as 100,000 cubic yards at Philadelphia Airport, which was that stockpile you saw in the yard. We have a 100,000 yard project with the Maine DOT going next year. So with that type of upfront on the larger projects, we've always been able to stay ahead of it. We try to keep about 50,000 yards in inventory at each of our facilities. But as we spread our footprint, that concern is actually getting diminished, because in Massachusetts, we plan on starting with 2 production lines. We have 3 in Philadelphia. We started with 2 in Florida. We'll have 2 in California. So the footprint is helping, but it's really keeping, most of our time is spent with the consultants doing the work for a lot of the agencies on this call, and just keeping in coordination with them, knowing what's coming up, and making sure we have that ability to stay in front of it. Not a perfect world by any means, but 7 years later, that's how we've managed our business. So we've never had to turn any projects down or say, hey, we can't manage that.
And I think I would agree with Archie on that. Having more plants are obviously going to add to that inventory and the ability to back each plant up. Again, using the JP Morgan Chase headquarters facility, a 2 million square foot project as an example that we've committed to and are actively supporting now, I think is hopefully a case that we can support it. Where our plant in Connecticut is intended to do about 50,000 tons or so of glass, and you can see how many yards that would be depending on your replacement of the pounds per yard in concrete. You can do a lot of concrete with that. I think in the Northeast, the New England states, I think, has roughly, if you use the old rule of thumb, of about 75 or 80 pounds of glass per person, I think you wind up around 500,000 tons of glass in the New England states. So we think the feedstock's there to find and use. I think we both share a concern that, I think what we're doing in the story we're telling is important for people to understand, and what we're telling on the climate side, that probably the best thing you could do with glass is to put it in concrete, is a little counterintuitive to the general population, who thinks the best thing to do is keep putting it back into bottles, because you keep going back to bottles and do it 6 times or 10 times. And our argument is, okay, you keep doing that 6 times, right? and you'll save roughly, I think the rule of thumb to melt glass and put it back into bottles is you save 1/6 of a ton of CO2 every time you do that. Put it in concrete, save a ton. So do 6 cycles of recycling back to glass, save a ton. Put it back in concrete, save 6 tons, well, more than 5 tons of CO2. So that I think counterintuitive story is something we have to continue to tell, because the concern is in issues like minimum content laws or other things, there's a potential for crowding out, I think, the opportunities that Archie and I are providing to the industry by diverting glass back to places where maybe it may not be the highest and best use. So I think that's something to leave you with as well as you think about legislative actions and how to use glass. It's something I think about a lot. I think we've got a solution. It hadn't been there before. I think it's forced a lot of people to think about other solutions for glass, but Archie and I are playing catch up here a little bit, I think, to provide these new businesses to the markets.
I was going to say, I'll add something real quick to this too, John. Our plant in Modesto, we're partnering with Gallo Wines. Gallo has their own bottling plant. They have their own cullet recycling plant. So even though they're going to be bringing glass in, Gallo knows there's a good portion that they can't use in their bottling in their container plant. So that's the smaller mixed cullet that's going to be screened out and coming over. The other thing that we didn't present, but will be announced more later this year in a larger scale, we are now doing ultra lightweight concrete using foam glass as the lightweight aggregate. So we're now looking at concretes under 100 pounds per cubic foot and over 4,600 PSI, which have a 65% recycled content. So we don't know of anybody that has done that. That we think that's pretty unique. And we're actually talking to Pat about the idea of using some positive as a cement replacement and now coming up with a concrete that can have a 75% recycled content and still maintain 4,500 plus PSI. So we think that's kind of a new, very unique thing to offer that we haven't seen on the market anywhere.
Oh, great. John, I think I want to be respectful of everybody's time.
Yeah, so I was just going to kind of circle back and say we'll share these presentations with everyone after the meeting, as well as provide a link to the recording. I know we had sent this out to a number of people who weren't able to attend, so we'll share that information following the call. So that will include contact information for Archie and Patrick if you guys have follow-up questions you want to ask directly of them. But other than that, I appreciate everyone's time this morning. Again, on somewhat short notice, I think it was great you could be here. Hopefully this information will be useful to you going forward. And I don't know if you want to add anything more to that, Greg.
I just want to thank Aero Aggregates and Positive for doing this, and I think it's something that we're going to try and continue in terms of these informational pieces that get the kind of discussion going between state agencies and various manufacturers of recycled products. And hopefully we can, if there's ideas or thoughts about that folks in the agencies have about, hey, they'd like to use it, but they need some help in some way, come talk to John and I, and we can figure out and provide some of the technical and financial assistance, hopefully, to try and make some of these pilots go forward and some of the successes, so we can mark them in Massachusetts and make these products kind of the norm here in the Northeast. So just thanks again, everybody, for participating, and we'll continue to stay in touch.
Thank you very much for the opportunity to be with you. Be well.
Thanks, everyone. Have a good day.